Welcome to basic trig substitution examples. So in this first example, let's go ahead and evaluate the indefinite integral, which is the integral of 2 over the square root of x squared plus 9 dx. So this is a case where we have plus. Right? So since we have the plus, we know that the triangle that we want to work with we'll have our we'll have the square root x squared plus 9 as our hypotenuse. In this case, we will put our x as our opposite. And then for our adjacent, this is plus 9 is plus 3 squared. So we will have a 3 as our adjacent. So again, when we have the plus, we automatically know that we fit this particular triangle. So our relationship involving x and the 3 is the fact that tangent of theta is equal to x over 3. That gives us that x is 3 tangent of theta. And of course, dx is 3 secant squared theta d theta. We also have our other relationship involving the square root and the 3. We have that secant of theta is the square root of x squared plus 9 over 3, or square root x squared plus 9 is equal to 3 secant theta. So if we perform our substitution, so if we substitute in, we have that the integral of 2 over the square root of x squared plus 9 dx would be equal to the integral of 2 over 3 secant theta. And then dx was 3 secant squared theta d theta. So this becomes simply, this is the integral of 2 times secant of theta d theta. The integral of secant of theta was just 1/2 times the natural log. Sorry, no 1/2. The integral of secant of theta was just the natural log of the absolute value of secant of theta plus tangent of theta. So we have 2 times the natural log of the absolute value of secant theta plus tangent theta, then plus c. At this point in, we substitute back in. We had secant theta was square root x squared plus 9 over 3. We also had the tangent of theta was simply x over 3. So we are looking at the integral is equal to 2 times the natural log of the absolute value of the square root of x squared plus 9 over 3 plus x over 3, and then plus c on the end. We can do a little simplification with this if you like. We can essentially rewrite this as square root x squared plus 9 plus x, whole thing over 3. And then splitting division in a natural log splits a subtraction outside the natural log. So we can simplify this. I'm going to give myself a little more space so I can do so. So from here, a possible simplification. We have, this is equal to 2 times the natural log of the absolute value of square root x squared plus 9, and then plus x, all in the numerator, and then divided by 3. Then we have plus c. Again, division inside the natural log splits a subtraction outside, so this becomes 2 times the natural log of the absolute value of the square root of x squared plus 9 plus x minus 2 times the natural log of absolute value of 3, and then plus c. Then we can just absorb that minus 2 natural log 3 into our constant. If we set c1 to simply be negative 2 natural log absolute value of 3 plus c. And so we wind up getting that our integral is equal to 2 times the natural log of the absolute value of the square root of x squared plus 9 plus x and absolute value plus c1. So our integral of 2 over the square root x squared plus 9 dx winds up giving us this answer. So that was one example of a basic trig substitution problem. Let's go ahead and do one more. So in this example, we are evaluating the indefinite integral, which is the integral of the square root of 4 minus 25x squared dx. You have some various manipulations you can do for this. I'm just going to build the triangle as is. So in this case, this is a 2 squared. So again, we are looking at 2 squared minus 5x squared inside of our square root. So this is a case where our hypotenuse is the 2. So when we go to set up our triangle, we will put that 2 on the hypotenuse. We have our theta. We will take our 5x as the opposite, and that's square root of 4 minus 25x squared as our adjacent. In terms of our trig relationships, involving the 5x and the 2, easiest thing to do is sine of theta. So we have sine of theta is 5x over 2. Or x is 2/5 sine of theta. And we get that our dx is 2/5 cosine theta d theta. So again, these will be convenient substitutions to have. That square root 4 minus 25x squared, relationship involving that and the 2, it's adjacent and hypotenuse, that's cosine. So we have cosine of theta is equal to square root 4 minus 25x squared all over 2. And we get therefore that square root of 4 minus 25x squared is equal to 2 cosine theta. Now we have all of our possible substitutions. So substituting in, we have the integral of the square root of 4 minus 25x squared dx is equal to the integral of that square root 4 minus 25x squared. We are swapping out for 2 cosine theta. That dx we are swapping out for 2/5 cosine theta d theta. This becomes 4/5 times the integral of cosine squared theta d theta. Here we are going to use power reducing. Let me update the screen quickly. Again, we are going to use power reducing. Cosine squared of theta is equal to 1/2 of, in parentheses, 1 plus cosine of 2 theta. And so our integral now becomes 4/5 times the integral of 1/2 times 1 plus cosine of 2 theta d theta, or 2/5 times the integral of 1 plus cosine of 2 theta d theta. At this point, we can do our integral. So this becomes 2/5 times 1 will go to theta. Cosine integrates to sine. So we will have a sine of 2 theta. And of course, to counteract that 2 inside, we should have a 1/2 out front. And then we have our plus c. So this is 2/5 times, in parentheses, theta plus 1/2 sine of 2 theta, and parentheses, plus c. Our job from here is to convert back to x. So we know that cosine of theta was square root of 4 minus 25x squared all over 2. We have sine of theta was x over 2. Sine of theta being x over 2 means that theta is sine inverse of x over 2. We're going to use a trig identity. So we are going to use the fact that sine of 2 theta is 2 times sine of theta times cosine theta. And so we have that the integral of the square root of 4 minus 25x squared dx is equal to, we have 2/5 times, in parentheses, theta plus 1/2 times 2 sine of theta cosine theta, and parentheses, plus c, or 2/5 times, in parentheses, sine inverse of x over 2. Oh, sorry, sine of theta was actually 5x over 2. So theta would be sine inverse of 5x over 2. So we have sine, our integral is equal to 2/5 times, in parentheses, sine inverse of 5x over 2 plus sine of theta was 5x over 2. And then we multiply that by cosine theta, which was square root of 4 minus 25x squared over 2. and the parentheses and add c. Again, this is a possible way to do that integral using trig substitution. There are other approaches we can take, but this one to me is the most straightforward.